10, 9, ignition sequence starts. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
Eagle Houston, we rig you now. You're a go for PDI, over. Roger, understand. We're go, same type, we're go. 60 seconds. Lights on. 40 feet down, 2.5. Picking up some dust. 30 feet, 2.5 down. Straight shadow. 4 forward. 4 forward, drifting to the right a little. 20, down a half. 30 seconds. Forward, just. Okay. Contact light. Okay, engine stop. APA at a descent. Mode control both auto, descent engine command override off. Engine arm off. 413 is in. We copy you down, Eagle. Houston, Tranquility Base here. The Eagle has landed. I'm at the foot of the ladder. I'm going to step off the limb now. That's one small step for man, one giant leap for mankind.
You have just heard the voice of the first man to walk on the moon, Neil A. Armstrong. A few minutes later, he was joined by Edwin E. Aldrin, Jr., his companion in space. They have done what men have dreamed about for centuries. They, along with their fellow astronaut Michael Collins, began their journey on July 16th, when their spaceship Apollo 11 was launched from Cape Kennedy, Florida. However, it was back on May 25, 1961, that President Kennedy decided to ask Congress for a program to send a man to the moon.
Space is open to us now, and our eagerness to share its meaning is not governed by the efforts of others. We go into space because whatever mankind must undertake, free men must fully share. I therefore ask the Congress, above and beyond the increases I have earlier requested for space activities, to provide the funds which are needed to meet the following national goals. First, I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth. No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space, and none will be so difficult or expensive to accomplish.
But did this journey really begin then, or must we go back still further? Not 10 or 20 years, or even 100 years ago, but perhaps 6,000 years ago, when the first civilizations were growing in the Middle East. The lonely shepherds watching their flocks in the clear Babylonian nights must have gazed long at the heavens and traced out the constellations such as Gemini, Taurus, and Orion. The sun, the moon, the planets, and the stars became strongly integrated with the religious life of the Babylonians. In fact, the first astronomers were the priests who watched the skies fervently and made notes on their clay tablets. Since life was so dependent on the sunshine and rain, every movement or change in the sky was noted as a sign that foretold the future on Earth. No battles were fought, no journey was undertaken, no marriage was performed before the skies were consulted. An eclipse was considered an evil omen.
Look! There is a shadow creeping across the sun. A disaster will befall us.
A famine! We must warn the king.
But at the sign of a ring around a new moon...
Look! Look! It is the sign that a new prince will be born to our ruler.
Through the centuries, the Babylonians learned a good deal about the heavens. Using their tables of lunar motion, they were able to predict fairly accurately when an eclipse would take place. They began to measure time by observing the phases of the moon. They followed a lunar month, beginning a new month every 29 or 30 days with the first appearance of the new moon. The year was divided into 12 lunar months, totaling 354 days. The solar year, a complete cycle of the 4 seasons, was determined to be 365 1/4 days. At certain intervals, an extra month was added to balance both the solar and the lunar year. But the Babylonians, like the ancient Hindus of India and the Mayas of Mexico, believed that the earth was flat and covered over by the dome of heaven, across which the planets and stars moved. The heavenly bodies became a part of their mythology or religion, and astrology, the art of telling the future by the stars, had its beginnings. It is still with us today. These Babylonian astrologers were particularly interested in the constellations that marked the ecliptic, the yearly eastward path followed by the sun. The 12 constellations in the ecliptic are called the signs of the zodiac. They are Sagittarius, the archer; Capricornus, the sea goat; Aquarius, the water carrier; Pisces, the fishes; Aries, the ram; Taurus, the bull; Gemini, the twins; Cancer, the crab; Leo, the lion; Virgo, the virgin; Libra, the scales; Scorpius, the scorpion. Each sign stands for a particular month of the year, but as the constellations move approximately one space each 2,000 years, the months on the astrology charts do not correspond with the positions of the constellations today. Though much of the work of the Babylonian astronomers dealt with superstitions and myths, they must still be given credit for launching the study of the skies. Remember, their only tools were the naked eye and the fundamentals of arithmetic, which they also developed. But they were the inspiration of the great Greek philosophers that followed.
The moon is a circle 19 times as large as the earth. It is similar to a chariot wheel, and the rim of the wheel is hollow and full of fire. This wheel cannot be seen, but its rim contains a round hole, and the fire burning inside that hole is the visible moon.
What? What did he say? Does he really mean that?
These are the words of the 6th century BC Greek philosopher Anaximander.
As the wheel turns, the hole turns with it, and phases and eclipses of the moon depend on the turning of the wheel. The sun, too, is a wheel, and is 28 times the size of the earth. It also has
Up to Anaximander's time, the Greeks had considered the heavenly bodies as part of their rich mythology. Helios and Selene and the other Greek gods and goddesses were the stars and planets. But here was Anaximander to say that the moon was not Selene, the goddess of the moon, but a wheel, and the same for Helios, the god of the sun. His theory may seem implausible to us, but it served to stir the minds of other Greek philosophers to a more realistic study of the heavens. Thales of Miletus lived at the same time as Anaximander, and he is sometimes credited with predicting a solar eclipse in the year 585 BC.
In honor of your great predictions, we, the citizens of this city, wish to reward you, Thales, with this bag of gold, and we will build a statue in your honor.
I do not need your gold or honors. My discovery is enough reward for me. Study and look with your eyes wide open, and you shall know as much as I do. This flat earth of ours is floating on an endless ocean.
But other Greeks were studying and looking at the skies, and they were coming to different conclusions than Thales and Anaximander. Anaxagoras in the 5th century BC made these observations.
The sun is a red-hot mass of fire. In size, it is larger than the southern peninsula of Greece. The moon is made of the same material as the earth. The light that it gives is only a reflection of the sun's light. It has no light of its own. The shadows on the moon are due to the mountains and craters that abound there. These craters are caused by meteors, which are flaming rocks, which originate on the sun.
Impious dog! The moon is the goddess Selene, riding her chariot across the night skies. You shall not dwell in this city.
Anaxagoras was driven from Athens by the angry citizens who were still loyal to heroes of mythology. Around this time, the 5th century BC, the Greeks began to abandon the theory of the flat earth. The Pythagoreans, followers of Pythagoras, set up a secret society.
Well,
May I have quiet, please? Please. We have several new members of our group today, and it has been requested that I review some of our basic thoughts about the universe. The entire universe is enclosed in a celestial sphere which rotates very slowly. Affixed to the outer sphere are the stars, and in the middle is the central fire. And around this fire, the Earth, the Moon, the Sun, and all the planets revolve. All of these bodies, including our Earth, are round in shape, and as they turn, they generate music.
How can that be? We've never seen the central fire that we revolve around. And did anyone ever hear this music that you speak of?
We do not see the central fire as our part of the Earth faces outward toward the Moon and Sun.
But do the people in India on the other side of the Earth see this central fire?
No. There is another Earth, our counter-Earth, which revolves between our Earth and the central fire, and shields the central fire. And the music cannot be heard by mere Earthlings.
It's a lot of metaphysical hogwash.
How is this possible?
I don't understand. The Pythagoreans were ridiculed and persecuted because they believed in the movement of the earth. And as their theories lent themselves to much argument, many men, including the great philosophers Socrates and Plato, believed that the study of astronomy was a waste of effort, other than its use for telling time. Plato's most famous pupil, Aristotle, did not share the convictions of his master. After much study, he evolved his own theories of the universe.
The Earth is at the center of the universe. It does not move. All other bodies move around it. At the limit of the universe is the prime mover, who is the source of all life. Beyond the prime mover is nothing, not even empty space.
Well, that I do not understand.
The heavens and earth are made up of entirely different matter, and they respond to different laws in nature. The earth is composed of 4 elements: earth, water, air, and fire. They are constantly changing into one another. The heavens are composed of ether, an element that never changes. Therefore, the heavens never can change. In the heavens, only perfect motion can take place. By perfect motion, I mean circular motion at a steady speed. It has no beginning and no end.
But many of the planets did not move in perfect motion. Mars, for example, sometimes traveled eastward and sometimes westward. Sometimes it was bright and sometimes it was dimmer. It moved quickly and it moved slowly. But Aristotle said that these appearances were deceiving, and all heavenly movement must be explained in terms of circular orbits at a steady speed around a motionless Earth. The explanation was left for other astronomers. About 50 years later, there came Aristarchus, a fine mathematician who stated that the sun and not the Earth is the center of our universe, and the Earth travels in a circumference around the sun. But against the weight of Aristotle's prestige, Aristarchus made little impression on the general masses. He was 17 centuries ahead of his time. Now we proceed to the last 3 Greeks in our saga: Eratosthenes, Hipparchus, and Ptolemy. Eratosthenes was born in 276 BC and was the director of the celebrated library in the city of Alexandria, which was founded by Alexander the Great. By an ingenious method, he was able to be the first man to measure the Earth's diameter accurately. Hipparchus was born in 150 BC and lived on the island of Rhodes. It was he who discovered the precession of the equinoxes and recognized it as a continuous process. His other accomplishments include the determining of the distance to the moon, the making of the first directory of the fixed stars, and the use of the epicycle, which is a small circle, the center of which moves around in the circumference of a larger circle. The epicycle was used to explain the irregular movements of planets. What we know of Hipparchus comes chiefly to us from the works of Ptolemy, who lived about 300 years after Hipparchus. He evolved the system that bears his name, which is a reworking of the use of epicycles, and with this, he was able to foretell the positions of planets and other heavenly bodies with much accuracy. However, he was firm in his belief in Aristotle's work and maintained that the Earth was the center of the universe and the Earth did not move.
If the Earth rotated, clouds and any of the things that fly or can be thrown can never be seen traveling toward the east, because the Earth would always be anticipating them all and forestalling their motions toward the east.
For the next 1,000 years, Ptolemy's system of the universe was accepted without question by practically all in the civilized world. Science had retreated to the position of the Babylonian priests 800 years before Ptolemy's time. It is May 24th, 1543, and we are in the cathedral of the city of Frauenburg on the coast of the Baltic Sea. The canon of the cathedral, Nicholas Copernicus, lies on his deathbed, paralyzed by a stroke. Into this somber room strides George Reticus, a young man who has been working with Copernicus for several years.
Copernicus, I have the finished book. It arrived today from Nuremberg. On the revolutions of the celestial bodies.
Let me hold it. It is my first printed work.
Now all of Europe will know of your new astronomical theories.
Oh, they are not all new theories. Some I learned from the Greeks, such as Aristarchus.
Oh, true, but we've been tied to Ptolemy's universe too long. Now you have shown that the Earth rotates on her axis, and that she revolves around the sun, along with the other planets. This book will revolutionize men's thinking.
However, Copernicus's work was not received with much enthusiasm. The Catholics and Protestants were both firmly tied to the universe as described by Aristotle and Ptolemy. During the 1,000 years since Ptolemy, the only major work in Europe in astronomy was done to correct the calendar. Even this important work had many roadblocks to overcome due to various religious rivalries. But in the Arab world of North Africa and the Middle East, scholars were translating the works of the Greek philosophers, which they found in the ruins of Alexandria and other great cities. By the 11th century, the Arab Muslim world had moved into Spain, and there the Christian scholars first learned of the great works of the Greeks and translated the invaluable Arabic translations into Latin. As books were still handwritten and few could read any language, the spreading of this knowledge took considerable time. But by 1473, when Copernicus was born, this knowledge was available in various schools and universities. By this time, people no longer believed that the world was flat, and the voyages of Columbus and Magellan more than disproved this fallacy. Copernicus's book was rejected by both Catholics and Protestants, as it could not be confirmed by the Bible or Aristotle's work, which had been made part of the Church's tenets. Some German and English astronomers tried to use Copernicus's calculations, but since Copernicus also believed in Aristotle's perfect circular motion of the planets and used epicycles to explain their variations, the astronomers found his system no easier than the Ptolemy system. After all, Copernicus had made only 27 observations to support his theories. Science demanded many more. Tycho Brahe, a Danish nobleman, was summoned in 1576 to appear before the king, Frederick II.
Your Highness, I am Tycho Brahe, and am here at your bidding.
Brahe, I have learned that you plan to leave Denmark to continue your astronomy studies in Germany.
That is true, Your Highness, but...
No buts, please. A true Dane would remain in his native land, and any good that would come from his work would reflect favorably on his own country.
But in Germany, there are many noted scholars who can help me in my work.
The scholars can just as well visit you as you them. What I am proposing is that an observatory be built for you on an island off the coast of Elsinore Castle. There you will have every convenience and necessity that is required for your work. Assistants, workmen, and servants will be at your beck and call. Do you accept?
I most certainly do.
Shortly thereafter, construction was begun on Oranaborg, and it had every convenience that an astronomer could ask for. With the aid of new instruments, the astrolabe, the quadrant, and the sextant, Brahe set himself and his staff to work with a fury. Every night for 20 years, they measured the positions of the stars and the planets. These undoubtedly were the most accurate observations made up to this time. But with this wealth of material, there was one problem. There was no one to interpret the data. Tycho Brahe was not a mathematician. Eventually, he left Oranaborg and settled outside of Prague under the sponsorship of Rudolf II. 1 year later, he was joined by Johannes Kepler, a young German mathematician.
Herr Kepler, I understand that you have quite a reputation.
Well, I have been fortunate to publish a book on astronomy.
A book? You young fellows think one book can sustain you for a lifetime. I have devoted over 20 years in collecting data about the heavens. The most complete measurements ever.
I look forward to inspecting your observations. They may help me in my work.
Now is not the time for such extracurricular activities. You shall help me in constructing new tables of planetary motion. They will be called the Rudolphine Tables, in honor of our sponsor.
1 year later, Tycho Brahe was dead, and Kepler was given his position, but at a much smaller salary. Kepler had promised to complete the Rudolphine tables for Brahe, but this was not done until 26 years later. Kepler had been busy with his own experiments. Using the many observations of Brahe, he was able, after a number of years, to discover the true course of the planets. They moved in an ellipse and not in a perfect circle. He also discovered that the speed of a planet varies, faster when it nears the sun and slower when it is further away. He also established a mathematical relationship between a planet's average distance from the sun and the time it takes to make a journey around the sun. These discoveries did away once and for all with the epicycles and other artificial devices used to plot a planet's path. In his time, Kepler received little or no rewards for his work, but in recent years, he has been considered as important, if not more so, than Copernicus and Brahe.
Welcome to Venice, Galileo. Are things going well at the University of Padua?
Well enough. I will only be in Venice a short time. Is there any news of interest since my last trip?
Political, ecclesiastical, or scientific?
All three. But first, the scientific news.
A Dutchman, Hans Lippershey, who is an eyeglass maker in Middelburg, Holland, has constructed an instrument which holds two glass lenses in a tube, one before the other. When one looks through this tube, distant objects seem near at hand.
What?
Oh, it's an amazing toy. And he's been aiming it at the weathercock on the church steeple for the amusement of the village burghers. But it has one drawback.
What is that?
Objects are all seen upside down.
Well, that does not really matter. But does one of these toys exist in Venice?
No, we've just heard the news from some travelers.
I suppose I will have to build one of my own when I return to Padua.
Galileo was a mathematics professor at Padua who had built a considerable reputation by his study of falling objects and his disputation of Aristotle's theories in the same field. Some claim that he dropped different weighted balls from the Tower of Pisa to prove that the speed of their fall is not controlled by the weight of the balls. In any case, Galileo was a doer, and when he heard of the spyglass, he just went and made one of his own. He visited the local eyeglass maker for lenses and launched a study of optics. As the lenses available to him were too small for his purposes, he learned to grind his own lenses. Galileo was one of the true Renaissance men, a master of many sciences and trades. He pointed his telescope not at church steeples, but at at the heavens, and what he saw astounded him.
The moon does not possess a smooth and polished surface, but one rough and uneven, and, just like the face of the earth itself, is everywhere full of vast heights, deep chasms, and shadowed curves. The fixed stars appear of the same shape as when viewed with the naked eye, but so much larger that a star of the 5th or 6th magnitude seems to equal Sirius, the largest of all fixed stars. But beyond the stars of the 6th magnitude, you will behold a host of stars, so numerous as to be almost beyond belief. And Jupiter has 4 satellites circling round her, just like the Earth's moon. Venus undergoes constantly changing phases, from a full orb to a thin crescent, and back again. It must be revolving around the sun.
Galileo published his findings in 1610 in a book titled Messenger from the Stars. A great furor greeted this work as it directly challenged the accepted system of Aristotle and Ptolemy and supported the theories of Copernicus. One strange result of this uproar was the placing of Copernicus's book on the Church's Index of Forbidden Books 73 years after it was published. Galileo was ordered by the Church to cease defending the Copernican theory and devote himself to other studies. For 16 years, until 1632, Galileo followed this injunction.
Now that my friend and a friend of science, Cardinal Barberini, is the Pope, I shall publish my new work, a dialogue on the 2 great world systems.
But Galileo was greatly mistaken. His new book was a powerful argument in favor of Copernicus, and though it was written cleverly to pass the Vatican censors for publication, it aroused bitter sentiment in the Church, and Galileo was ordered to appear before the Inquisition.
We ordain that your book be prohibited by public edict. We condemn you to the formal prison of this holy office during our pleasure. And by way of salutary penance, we enjoin that for 3 years to come, you repeat once a week the 7 penitential psalms, reserving to ourselves liberty to moderate in whole or in part the aforesaid penalties and penance.
I recant all that I have written, that the sun is the center of the universe, and that the earth is not the center and moves.
This Inquisition proceeding is over.
And yet, it moves.
Galileo, now 69 years of age, spent the 10 remaining years of his life under house arrest in his villa near Florence. He was allowed to continue his work in fields other than astronomy. Though he had lost in the courts of the Church, Galileo and his telescope had struck a fatal blow at the theories of Aristotle and Ptolemy. Men all over Europe could now look for themselves at the skies and see the truth of Galileo's observations. There remained one major mystery. Why did the planets revolve around the sun and the satellites around the planets? The answer to that would firmly and finally put to rest Ptolemy's concept of the universe. The genius who tied together the work of Copernicus in Poland, Kepler in Austria, and Galileo in Italy was Sir Isaac Newton. Born in England in the same year that Galileo died, 1642, he was educated at Cambridge University. After graduation, he continued his studies there for his master's degree. During this period, and a few years afterward, Newton produced some of the greatest scientific discoveries. The major discovery was his law of gravitation, which explained the attraction of all bodies in the solar system. This would explain Kepler's laws, but he needed a special type of mathematics for his research, so he invented calculus. Newton studied optics and discovered with the aid of a prism that a white light could be split up into its component colors. He also perfected the first reflecting telescope, explained the cause of tides, the bulge at the Earth's equator, and the reason for the precession of the equinoxes. But his 3 laws of motion were his major triumphs.
A body will continue in a state of rest or uniform motion
unless acted upon by a force. To every force, there is an equal and opposite reaction. Acceleration is equal to force divided by mass.
With these laws, the science of physics could begin. With the solid foundations set by Copernicus, Brahe, Kepler, Galileo, and Newton, the science of astronomy made rapid strides from the mid-18th century onward. Men's imaginations were stirred, and they began to dream of voyages to all parts of the world, and to other worlds as well, especially the moon. Back in the 2nd century A.D., Lucian of Samos wrote the first fictional account of a trip to the moon and called it the true history. 1,500 years went by before the second fictional trip was written by Kepler, the great astronomer. Then other books appeared, written by Bishop Gedwin, Bishop Wilkins, Cyrano de Bergerac, and Edgar Allan Poe. Some of these were pure fancy, as they imagined the trip to be taken on the wings of birds or in flying boats. With the introduction of balloon flights in the late 18th century, men realized that a trip to the moon would require something special to escape the Earth's atmosphere. This special device had its origin in old China about the 7th century A.D. The rocket was that device. At first, rockets or skyrockets were used as part of the fireworks display for festivals. By the 13th century, the Chinese had turned the rocket into a weapon of war against the Mongols. Shortly thereafter, the rocket weapon was being used in Europe, but at the same time the gun was being developed. Eventually, the gun, because of its far greater accuracy, became the standard weapon, and the rocket disappeared as a weapon by the 16th century. 300 years later, in 1806, British men of war appeared off the French port of Boulogne. It was the time of the Napoleonic Wars. William Congreve, a British aristocrat and inventor, is on board.
Well, Mr. Congreve, this is the second chance you'll have to demonstrate the worth of your rockets. The last time we were off Boulogne, they didn't work very well.
True, but the wind then was very unfavorable.
We have little wind now, and the French fleet lies there in the harbor at anchor. Are we ready?
Captain, the rockets are ready. They may commence firing now.
The French were terrified of this new weapon, and they did not return one shot. The rockets had been aimed at the fleet in the harbor, but they overflew their mark and landed in the port itself and did considerable damage. Congreve went home to further perfect his rockets. William Congreve's interest in this type of weapon began when he heard a report of Indian soldiers using rockets in their warfare against British troops in India. He thought that rockets would be an ideal weapon to use against the fleet of Napoleon, which was supposedly massing for the invasion of England. In his first experiments, he used the sky rockets being made then for fireworks. Eventually, he built larger ones, capable of carrying explosives and fire bombs, and the success of the attack on Boulogne led to the establishment of rocket brigades in many armies. The American national anthem mentions the rocket's red glare, which refers to the British's use of rockets in their attack on Fort McHenry. But again, within 50 years, the war rocket disappeared, beaten by the increased accuracy of long-range artillery. The rocket survived in two peaceful uses, the line-carrying rocket and the signal rocket, and of course as part of a fireworks display. But the interest in rockets continued. In the 1860s, a French writer, Jules Verne, launched a new direction in adventure stories. His tales of unusual journeys were not based on pure fantasy. Instead, he based them on the latest scientific knowledge, which made his tales all the more believable. His many books were the inspiration of youths throughout the world to work in the fields of science. And as his work was continually checked by scientists for accuracy, this led to more experiments and calculations of the needs for space travel. Possibly due to the fact that Russia was the last nation to give up on war rockets, that country was to give the world the first rocket theoretician, Konstantin Edvardovich Ziolkovsky, who later said that he was inspired by the novels of Jules Verne. Ziolkovsky's most famous work, published in 1903, stated that a rocket would be the best means of traveling in space, and liquid fuel would produce a much greater exhaust velocity than solid fuel. Ziolkovsky's work was largely ignored until the mid-20s, when space travel began to stir interest in Europe and the United States. Then the Soviet government acclaimed Ziolkovsky a hero and reprinted all of his works. By now, Ziolkovsky was 70 years of age. On March 16, 1926, Robert Goddard and his wife and 2 assistants went to the farm of Miss Effie Ward outside the town of Auburn, Massachusetts. There they set up a 4-pole launching stand. Within this frame, they placed a 10-foot rocket fueled by liquid oxygen and gasoline. They ignited this. The era of modern rocketry had begun. This was the first liquid fuel rocket ascent. It reached an altitude of 41 feet and traveled a distance of 184 feet. Its fuel lasted 2.5 seconds. Robert Goddard had been working with rockets since being inspired as a teenager by H.G. Wells' book, The War of the Worlds. His experiments continued through his college career and as an adjunct to his work as a physics professor at Clark University. Without knowing of Ziolkovsky's work, he had come to the same theoretical conclusions. But in addition, Goddard was a doer, and he built many experimental rockets. As the rockets grew in size, he experienced resistance from the local authorities, who feared the rockets would bring injury to the neighboring communities. Goddard needed open spaces, and in 1930 he moved to the outskirts of Roswell, New Mexico, where he set up a staffed rocket research center. For 12 years, Goddard built and developed rockets whose features are essential to modern space technology. If we are to call Robert Goddard the father of American rocketry, then Hermann Oberth is the father of German rocketry. Oberth was a 27-year-old mathematics student at Heidelberg when he read of Goddard's work. He had already been working several years on the problems of rockets and space travel and had drawn up plans for a passenger-carrying spaceship. This was published in 1923 as The Rocket into Interplanetary Space, and though it was originally attacked by some scientists, it became the Bible of German rocketeers. Interest in rocketry grew in Germany, and an organization, the Society for Space Travel, was formed. Eventually, they successfully launched 87 rockets and created a great deal of interest throughout the world. A combination of an economic depression and the rise of Hitler to power in the early 30s caused the organization to collapse. Some of its members, like Wernher von Braun, went to work for the German army, where they eventually developed the dreaded V-2 rockets of World War II. Others, like Willy Ley, left for the United States to continue their rocket work. After World War II, work on rockets continued at an accelerated pace. V-2, Viking, Nike, the Vanguard were in the headlines. Then, on October 4th, 1957,
the Soviet Union launched today an artificial satellite into orbit around the Earth.
This was the beginning of the space age.
January 31st, 1958. The United States achieved its first successful satellite launching, placing the 30-pound Explorer in an Earth orbit.
January 7th, 1959. The Soviet space vehicle became the first man-made planet when it went into orbit around the Sun.
March 31st, 1959. The United States launched its first successful lunar probe, Pioneer 4, which also went into orbit around the Sun.
April 12th, 1961. Soviet Major Yuri Gagarin became the first human space traveler when he was launched into orbit in Vostok 1.
May 5th, 1961. Navy Commander Alan B. Shepard, Jr. became the first United States astronaut when he rode the 4,000-pound Freedom 7 Mercury capsule 115 miles into space. February 20th, 1962. Marine Lieutenant Colonel John H. Glenn, Jr. became the first American to make an orbital flight in his Friendship 7.
March 18th, 1965. Soviet Lieutenant Colonel Alexei Leonov stepped out of his space capsule for a 10-minute spacewalk.
June 3rd, 1965. Air Force Major Edward H. White became the first United States spacewalker, remaining outside 20 minutes.
February 3rd, 1966. The Soviet Union's Luna 9 made the first soft landing on the moon.
June 2nd, 1966. The United States Surveyor 1 duplicated the Soviet soft landing. October 11th, 1968. The first manned Apollo spaceflight, Apollo 7, carried 3 United States astronauts into Earth orbit. July 20th, 1969. The United States Apollo 11 flight lands 2 men on the surface of the moon.
It says, "Here men from the planet Earth first set foot upon the moon, July 1969 AD. It came in peace for all mankind."
The achievements of both nations have been great. Men have now reached the moon. But is this the end of the voyage? Men will continue to seek and explore the unknown. In a state of rivalry, they have done well. But in a friendly, cooperative relationship, they can do even more.